One wrong step and it was all over.
It was so terrifying. And there was so much pink.
Studies from Johns Hopkins University show that 100% of students during their time in Dr. Young's Applied Chemical Equilibrium and Reactivity class will experience a titration experiment.
But you don't have to be a victim.
The cycle of torture can stop now.
You can control titrations without letting them control you.
Don't be scared. Be prepared. With proper preparation, you can get an endpoint that looks like this. And avoid one that looks like this. First, after a good night's sleep, or as best as you can get on these twin beds, get up and have breakfast. Now that you've fueled your brain, it's time to do pre-lab calculations. Next, sit in a quiet room to do your pre-lab calculations. Open your computer to Chem 21, then quickly shut your computer out of frustration. Before you remember, ma'am. At the equivalence point, moles of acid equals moles of base. Let's look at a weak acid strong base example. 500 milliliters of 1 molar nitrous acid is titrated with 1 molar NaOH. What is the starting pH of HNO2, and how many milliliters of NaOH must be added to reach the equivalence point? At first, this may seem like a difficult problem. However, you are a smart cookie who paid attention in Dr. Young's lecture, so you know that the first problem is an ice table problem. Setting up our equilibrium expression, we see that the concentration of H+ ions in solution will be equal to X. We can plug this into our equilibrium expression where Ka is equal to the concentration of NO2- ions times the concentration of H+ ions, all divided by the concentration of HNO2 ions in solution. Our Ka value for nitrous acid is 5.6 times 10 to the negative fourth. Our initial concentration, 1 molar of nitrous acid, is much more than 1,000 times this Ka value. Therefore, we can make the X's small approximation. When calculating, we can see that our concentration of H+ ions in solution at equilibrium is 0.02366 molar. Thus, the pH is 1.6. Now, what about the volume of NaOH? Easy! You remembered, ma'am! Moles of acid is equal to moles of base at the equivalence point. First, we calculate the moles of nitrous acid present from the initial molarity and the volume. We note that the moles of acid are equal to the moles of base at the equivalence point. Finally, use the initial molarity of NaOH, which is 1 molar in this scenario, and 0.5 moles at equilibrium, to find the volume of base added. 500 milliliters. Wow! You can do chemistry! Easy! Now what about the actual experiment? Make sure to wear gloves, splash goggles, and a lab coat at all times since you could be working with corrosive chemicals. Use teamwork to slowly titrate your sample and constantly swirl so your indicator is accurately showcasing the additions of base. Finally, remember that your endpoint is approximately 1 drop past your equivalence point. And that's it! If you follow these tips, you are sure to conquer this titration. Don't be scared, be prepared.